everybody, it's me. Each time I do these videos, I'm trying to pull all of the stuff that you're reading and the activities I'm trying to give you together. And so basically, I just want to, reconfirm why we're doing this. The idea is that, we are enhancing our mathematical practices as teachers, which means that we're really getting the kids to their mathematical practices, which is part of their standards. And in addition to that, we're trying to get ourselves more comfortable in finding the love of math so that we don't omit the math within these STEM challenges that people are doing more and more and more and more. And just to kind of clarify, I mentioned it a little bit in the first slideshow because I feel like a lot of people have read it, but if you haven't read Joe Buller's Mathematical Mindset, really what part of why this has come to be for me is because we want to make sure that we are getting kids to love math and that we are not promoting stereotypes that, you're either good at math or not good at math. I felt like that as a child, and because of her work, I have found the love of math, and now I'm a math-tosa. And so what can we do to make sure that we're not passing those stereotypes on to our students and we're really helping them find love? And so I like to say, let's make, what is it called? Making math great again. Anyway, so hopefully that's kind of what we're doing. We're doing it through rigorous tasks, engaging them in activities, and then this week is all about discourse. So I'm going to talk to you a little bit about the 2 discourse articles and then the activity as well. So something to think about, we're enhancing our mathematical practices, we're enhancing our comfortability with math so we can help find the love. And then the last one is part of this rigorous tasks and best practices and getting kids to persevere is doing it within the context of science, technology, engineering, and math all together. So I don't know that I've given you so many examples, but the idea of having me is my bag. That's my expertise. And so I plan to just give you feedback all along the way and just grow you where you are, and hopefully you can really, the benefit of this class will be my expertise one-on-one with your posts and with your papers, and, as you create this STEM unit. You're also going to benefit from your teammates or your colleagues that are on in this class. So a couple things to think about is with the discourse articles, we read one discourse article from Principles to Action, and I'm sorry this always comes out reversed, and Minds on Math. And what I want you to think about for Minds on Math is basically that they talk about discourse. The chapter is also referring to the workshop model. I don't want you to worry about the workshop model. The workshop model is something that they promote, but it's about creating meaty tasks. It's the workshop model. This whole premise is, creating the meaty tasks, which is what we want to do. But also it's about you modeling the thinking and the concepts and then giving them more work time and less talk time as a teacher. So don't really worry about the workshop model. Really dig into the kinds of things that they want you to be doing. They are the experts. I'm here to facilitate all of our learning. I'm going to go back and read all these articles at the same time as you guys again. But the Minds on Math, sorry, I'm going to check my notes here, is really just getting kids to talk about their mathematical thinking, creating experiences where not only are you asking them to do it, but they want to. And that's why I believe in the science. They give lots of examples that are very, not cookie cutter, but like our typical math, like we're making cereal boxes and, it's not necessarily contextualized. So what can you do to take their learning and contextualize it in, your science unit that you're doing, or even your social studies unit that you're doing. So I really want you guys to be thinking about that. And, I think that's, in the second article that you're reading, to kind of pull it together, they talk about facilitating meaningful discourse. And again, they have ideas, and they're going to help you get to the meat of what you should be doing in your classroom as well. I don't know why. Oh, I know. I was going to refer to these. So I think that these 8 mathematical practices for us is what's getting us to get kids to their mathematical practices. And, by getting kids to talk, you're kind of doing a lot of these all together. And so when I see that, you want to get kids to reason and problem solve, well, by them knowing that they're going to have this mathematical discourse with their peers, they're going to have more reason to have to explain their reasoning and really persevere on the problems. Then this last standard, elicit and use evidence of student thinking. I mean, that's the purpose of the discourse. I mean, I see so many teachers, if they get to the talking and the reflection, they have them leave their papers behind because, they rattle them and whatever. But what can you do to have the proof right in front of them? And so they're saying, see right here, see this picture that I made, see this visual? And so you're kind of using all of these together with the discourse. The discourse gives students the authentic purpose to talk to their peers about it. And again, it's getting kids from just this memorize your facts to putting it in a context to develop the concept. And that's this one right here, build procedural fluency through conceptual understanding. And so I just wanted to get you guys to see how we can't master all of these. I'm not trying to introduce all of these, but discourse would be a one where I really believe you're getting your bang for your buck. These two articles that you read didn't necessarily emphasize the transdisciplinary nature that I am, but I just want you to be ready for that. So part 2 of this week is kind of like you did your mathematical progression for the subtraction problem, right? What kind of math did you need to access that subtraction problem in 2nd grade? We're also going to have a challenge this week where you have to kind of backwards design from surface area and volume all the way back down to cardinality and counting. What little steps are in the way that allow a child to find surface area, that allow children to know the difference between area, surface area, and volume. So that's kind of where this week's assignment is going. You're going to post that on the website. And to be clear, I'm just pushing you to put it out there, and if it's all wrong, like I tell my students, it doesn't matter. Your brain grew. I mean, that's what that mathematical mindset research says, is that, even if you persevere on something, that your brain synapses are growing. So don't worry about, if I missed a part of the progression or anything like that. It's all about kind of pushing ourselves out of our comfort zone this week. And again, I'm going to give you feedback to help grow you. That volume unit, I'm saying, is embedded in, I was looking at the new 5th grade standards and the old 5th grade standards because I know, most people are probably using the old 5th grade science standards. But so that volume unit is kind of tied to a lot of what you would do with matter because you're really trying to teach kids how, if you combine this trail mix, the weight of the individual things come together and the weight doesn't change. Although the standard says there's no difference between mass and weight in 5th grade. A couple things to think about. I hope that makes sense. Please email me, call me. I'm here to help you all along the way. So hopefully that makes sense, and thanks.